This is a very short video to show you how choosing axes can make a big difference to whether or not you can see what's going on with data. Now this looks like it's a curve going down and you can see what's going on in the first bit, and in the bottom bit it looks like there's no detail at all. Now you may be able to see there's a little kink in the data there, and that suggests that maybe other things are going on, and you may possibly be able to see just there that there's something strange going on. Now, the way that we can do this is, instead of representing this as a linear scale and the vertical and horizontal as linear scales, we can try doing logarithmic scales. And if by plotting a log linear plot, well, there's three ways we can do it. You can either put log scale on the vertical, linear on the horizontal, linear on the vertical, log on the horizontal, or log on both, and they tell us different things. So a log tells us whether the relationship is a power relationship, and if it is, it's a straight line. And log linear tells us if either of the variables are exponentials. So if we try putting format axis and we can click logarithmic scale on that one, and all of a sudden you can see there's a lot more detail in there. Now there's one bit that's a straight line in there, definitely a straight line. So that bit is likely to be an exponential relationship. All the rest are very slight curves. So that probably isn't. If we go back and take that logarithmic scale off, try doing a logarithmic scale on the horizontal axis, that doesn't really help us very much. That doesn't show us very much at all. It even looks even more curved than it was in the first place, so that's probably not very useful. But if we do a logarithmic scale on both, that one gives us a very different relationship. In there, you can see we've got a nice straight line there, a nice straight line there, a couple of straight lines there. That actually, if you look very carefully, that is actually a slight curve. But the fact that a log-log relationship gives us lots of straight lines suggests that bits of this are actually power relationships. So 1 over x, 1 over x squared, or 1 over x to the 2.7 or something. And from the gradient of that graph, we'd be able to tell what the actual power relationship was. Now, this data actually is made up of 5 parts like that. And if I do it in the different colors, then it becomes a bit more obvious to see these bits of it. So you can see now that the different bits of it are at different gradients. And if we try putting the logarithmic on the other axis as well, does that actually show us anything different? Well, there we go. We've got a double logarithmic, and that's showing us that. If we take that one back to linear, again, not too much use. So it's the double logarithmic that probably gives us the most useful in this particular case. So it's important that if you have a set of data that looks like maybe it's just disappearing to nothing after a small part of it, but you've got a load more data, there may well be a lot more information hidden in there that looking at it as a logarithmic might be a more useful way of demonstrating that there is some change in the data.